number 6 here. Continuing on with Chapter 3, Section 1, solving system of equations by graphing. So I've got a blue equation, and I've got this awesome magenta equation. Now I'm going to solve these more traditionally, just changing things to y equals mx plus b. You'll notice that the blue equation is really, really, really close to y equals mx plus b. All right, we have what? 5x minus y equals 4. We don't want a negative y, we want a positive y, okay? So probably most of you probably took away 5x from this side, and then you took away 5x from this side, and got negative y equals negative 5x plus a 4. And then if we don't want a negative y, you can either divide all of these numbers by a negative 1, or here's another method. Instead of dividing everything by a negative 1, you could just multiply everything by a negative. What's a negative times a negative? Positive. What's a negative times a negative 5? Positive 5x. And what's a negative times a positive 4? Negative 4. So what I'm saying is you can distribute this negative sign to every single number. So either you can divide everything by a negative 1, or you can multiply everything by a negative 1. You have options. Okay. You didn't do that? You probably did. What did you move? Did you take the y and move it across? And then you took the 4 and you moved it across? There you go. That's another option. Because if you move the negative y across, you get a positive y. If you take the 4 and you move it across, you get a negative 4, and you get the same exact answer. So guess what? In math, you have options. All right. Now, what's the slope of this? 5. And what's the y-intercept? Negative 4. So I'm going to go down. Negative 1, negative 2, negative 3, negative 4. And a slope of 5 actually means what? 5 over 1, which means I need to go up 5 and over 1. Up 1, 2, 3, 4, 5, over 1. Put a point. Connect your dots. Boom, you've got your line. Now that was a little bit easier one because all we had to do was solve for 1y. It's pretty easy. Now we're going to go down here and look at the next one. The next one says negative 2x plus 6y equals 4. Now, if I wanted to isolate the y's, what do I have to do to get rid of this negative 2x? I better add 2x to both sides. But I can't combine those because a 4 and a 2x, those are not like terms. That's very good. So what do we have left? We have 6y equals, now I could say 4 plus 2x, but watch what I'm doing. I'm going to move the x's up front and the coefficient, or the constant, just move it in the back. 2x, move it up front. Now what are we going to divide everything by? Okay, let's do it. Divide by 6. Divide by 6. Divide by 6. And we get y equals 1/3 of x plus 2/3. Now some of you might be going, what the heck did you just do? But 2 over 6 reduces to 1 over 3. And 4 over 6 reduces to 2 over 3. So now guess what I have? I have my slope. I have my y-intercept. So there's my slope, there's my y-intercept. Now what can you do? You can use your graphing calculator, type it in, hit y equals, type in 1 divided by 3x plus 2 divided by 3. Check your what? Check your table. Okay, I'm going to check it out. Right there, Jacob, I say negative 2, 0. Guess what? I'm just going to use that right now. I'm going to use that point right there. Negative 2, 0, which is right there. I only technically need 1 point, because guess what I've already figured out? We figured out the slope, which is a 1, 2, 3 ratio. So watch this. From negative 2, 0, guys, we're going to go up 1 and we're going to go over 3 units. And we're going to be really excited because we can realize that our lines share a point. Up 1, over 3. Just to make the line accurate, we want to graph at least 3 points, because redundancy leads to accuracy. I have a friend who's a surveyor. His name is Willis Johnson. He's awesome. He taught me that. He said, by the way, when you're a surveyor, you do things over and over and over again because redundancy leads to accuracy. And that's a horrible line. I'm trying to. Still not a good line. Try one more time. I know it's feeling a little redundant, but now it's a lot more accurate. Oh, we have jokes. Not good ones, but. And what is that ordered pair, my friends? I'm sorry. One. Which is our solution at 1, 1. Okay, so let's look at our last few problems, okay? The last few problems so you know what I'm asking you to do. We zoom out. Okay, here we go. Last few problems. It says, graph each system of equations. So you can graph all those. Okay? And then says, label them, or sorry, describe them either as consistent and independent, consistent and dependent, or inconsistent. Alright? So what I'm going to do right now is I'm going to do number 7 and show you what I'm looking for. Alright, number 7 we have 2x minus y equals 4. And we also have x minus y equals 2. Alright? So if I wanted to solve for this one, I could do the Jordan method, just throw that across, get y equals. Take this 4, move it across, get a negative 4, right? So it's 2x minus 4. Alright? Jordan, would do the same way on this one? Go for it. Alright, we take this negative y, what do we do? Throw it over here, get a positive y. Take this 2 over here, what do we do? Throw it over here, make it a negative 2. We have what? Y equals x minus 2. So if you don't like that method, that's okay. Do it however you feel like it. Just make sure it's right. Alright? So, we have this equation, 2x minus 4. We have this equation, x minus 2. What's the slope of this guy? 2. What's the y-intercept? Negative 4. By the way, if you're watching this video, feel free to pause anytime you want. You can even mute if you want to. I know some students would like to mute me a lot. But you can only do that from home. Alright, so let's graph these. We've got 2 and a negative 4 right here, so let's hear it. Negative 4. Negative 1, negative 2, negative 3, negative 4. We got to go up 2 over 1, up 2 over 1, up 2 over 1. Connect the dots. That's still not a very good line, but you know what. There we go. Now we're going to do the other line. My slope is 1. My y-intercept is negative 2. So there we go, negative 2. My slope is 1. Ooh, I see where they cross. Now, Jacob, did I ask you for when these cross?
No.
I did not, did I? I just asked you to tell me, is it consistent and independent, consistent and dependent, or inconsistent? Which one would it best describe?
Consistent and independent.
Consistent and independent is correct because whenever you have 2 lines that cross, that's how we name them. So on your paper, after you graph them, you would write, Mr. DeVid, this is consistent and independent. There you go. So basically, I think we've done, if you watch these videos,